Welcome to PM Ready, your guide to becoming PMP certified. This is the lesson on Quality Tools, Part 2. A logical data model is a visual representation of an organization's data, or at least that portion of the data that's of interest for your project, or for a particular operation or process. Representing this data visually helps you understand the details of the data and how it's all related and connected, so you know how to use it, how to update it, how to change it, and how to build or extend databases for the data. A logical data model is meant to be simple. Your database administrators can and often will make this more complicated. For what they need to do, they need to be more detailed. However, for you, the most important use of a logical data model is to work with the users to come to a mutual understanding of the data. So you don't want diagrams that are too complicated to use with non-technical people. And they really don't have to be anything but simple diagrams to get nearly all of the value out of them. Your database people can always come back later and add the details that they need. Let's take a look at a very simple example. Here on the left, you have just a portion of a data model for customer orders. It starts with the customer as an important object or entity in this model. Each object or entity then has attributes, such as the customer's name, physical address, and email address. In a real data model, you'd have many more attributes, such as billing address, credit card information, and more. Next, we have the order object, which has attributes of an order number and an order date. Each order then has items, and each item has a SKU, a quantity, and a unit price. SKU, by the way, stands for Stock Keeping Unit, which is simply a unique ID that a vendor gives to each type of product. For example, at a grocery store, bananas will have one SKU, while pineapples will have another. This data model is sufficient to let you know who bought what, when they bought it, how much they spent, and where it was shipped to, and how to contact them by email. Such logical data models are known as entity relationship models because they show the entities or objects and how they're related to each other. In this case, you see that customers are related to orders and orders are related to items. These relationships can also be specified more precisely. In this case, the model indicates that each customer can have multiple orders or no orders at all, and each order has at least one item in it. These details are represented by the little marks on the ends of the lines that connect these entities. However, these little marks are not easy for users to learn or remember. So I usually just write 1 to N on the line to indicate that each customer can have multiple orders, and each order can have multiple items. And it's not usually very helpful to distinguish between whether, say, an order has to have at least one item. When setting up your database, it's natural that some relationships can have nothing there, such as a customer that has no orders. That's easy. It takes more work to set up a restriction so that at least one is required, such as an order must have at least one item. Adding that restriction takes more work and adds complexity to the system that may do more harm than good. Or it might add a valuable check that prevents bad data from being put into the system. Either way, these nuances are usually best determined by the development team. Logical data models can also help you identify data integrity or quality issues, not only with the data, but with the model itself. In our simple example, notice that it only allows for one address, when it should, in most cases, allow for at least a billing address and a shipping address. Also notice that it doesn't allow for different orders to have different shipping addresses for the same customer. It's extremely valuable to explore such limitations of the data model before starting to build the system, and then having expensive rework to fix it later, or worse, having to live with limitations and odd workarounds for years, such as having to set up different customer accounts for the same customer in order to ship to multiple addresses. You may wonder whether something should be an attribute of an object or a separate object with a relationship between the two. This is a good question, and it's beyond the scope of this course. But I can tell you that it doesn't matter as much at this level when you're working with the users to define the high-level data model. Your database designers will have experience and insights that they'll use to modify this high-level data model into a more detailed and precise one that they need. And they'll often create objects for attributes for technical reasons. Those of you with database experience will recognize that the diagram on the right is closer to what most database tools actually generate for a logical data model or entity relationship model. And I've omitted some of the details, such as the IDs that are needed to support these relationships. A flowchart can be used to represent a process map or process flow. It begins with a starting point, which leads to different processes or activities to be done, connected in the order in which they should be done. It also includes decision points, which lead to different branches of activities depending on the decision. The process is complete when you reach the end symbol. Here you see a very simple example of turning on a lamp. The first step is to turn on the lamp and see if it works. And if it does, you're done. This is the typical path through this flowchart, in which there are no issues or complications. And so this path is sometimes called the happy path. On the other hand, if the light doesn't come on, the flowchart branches to have you check the plug. And if that works, you're done. Otherwise, you branch to the step of replacing the bulb and possibly having to repair the lamp. Flowcharts such as this, but with many more steps, are often used to represent standard operating procedures for well-defined processes, things that need to go a certain way and be very consistent. Also, tasks that are dangerous and for which specific safety steps have been defined to minimize risk. Flowcharts traditionally use these oval or rounded rectangles for the start and end symbols, rectangles for processes or activities, diamond shapes for decision points, and other symbols to represent documents, databases, external systems, and so on. However, many flowcharts don't use these traditional symbols, but still maintain the essence of showing the order in which things are done, often with possible branches to take under different conditions. A Xshaped diagram is a simple but common example of a high-level flowchart that's used in Six Sigma processes to model existing processes that are being analyzed for process improvement. Xshaped is an acronym that stands for suppliers, inputs, processes, outputs, and customers. A Xshaped diagram shows the flow of inputs from suppliers to processes that turn these inputs into outputs and then go to the customers. It also shows that requirements and feedback are sent from the processes to the suppliers and from the customers to the processes. Note that suppliers can be internal or external to the organization, and that inputs and outputs can be raw materials, resources, services, or even information. Flowcharts have a number of different uses. One is to communicate process flows, such as standard operating procedures, in order to maintain consistency, ensure compliance, or maximize safety. They can be used to understand the process flow of operations as well as project activities. For both operations and projects, they can be useful in identifying potential or actual quality issues, where they're happening or where they're most likely to happen, and where to incorporate quality checks and process changes. Seeing the whole picture and all of its steps can also help you to do a bottom-up calculation of the total cost of quality for a process. Next, we have activity diagrams. We'll start with the activity on node diagram. This should look familiar to you because it's the type of diagram used in project schedule management for project schedule networks that show the various project activities and their dependencies, but without yet showing the durations. Precedence diagrams, which use the critical path method, are also activity diagrams, but with the durations added, along with early start and finish dates, late start and finish dates, and total float for each activity. As the name suggests, the activities are shown on the nodes of the diagram, depicted here as circles with letters in them. And the relationships between the nodes are represented as arrows connecting them. You'll sometimes also see activity diagrams with the activities on the arrows instead of on the nodes. Such diagrams are called activity on arrow diagrams. These aren't used as often because they're more limited in the relationships that they can represent, which can require you to introduce what are known as dummy nodes. For example, if activity D is a predecessor to activities C, E, and H, this could be represented easily on an activity on node diagram by showing multiple arrows coming from D, and each of these multiple arrows going to one of C, E, and H. However, on an activity on arrow diagram, you have to introduce a dummy node or dummy arrows that have no activities in order to capture this relationship. To summarize, activity or arrow diagrams are used to create the project's schedule network diagram using the precedence diagramming method in the sequence activities process. It's then expanded using the critical path method in the develop schedule process. Even flowcharts are a specialized type of activity or arrow diagram. Activity or arrow diagrams come in two basic types, those with the activities drawn on the arrows and those with the activities drawn on the nodes. Activity on node diagrams are more common because activity on arrow diagrams are more limited and require dummy nodes or arrows to represent some dependencies or relationships. An interrelationship diagram, or digraph, is an activity on node diagram that's used to show cause and effect relationships between different items. In this sense, it's like the Ishikawa or fishbone diagram, but the arrows can go every which way, including in loops. And the relationships can be just about anything, and they can be all combined on a single diagram. They can include dependencies, risks, assumptions, constraints, stakeholder relationships, communication channels, any sort of cause and effect or influence relationship. The nodes can be taken from earlier analysis, such as brainstorming, affinity diagrams, or Ishikawa diagrams. The items are added to the interrelationship diagram, and then arrows are added with details of the relationships. Such diagrams can be used to represent project activities and their relationships. And this information can then be used in simulations such as Monte Carlo analysis. Or they can be used to understand a problem or complex system, or to do root cause analysis. Matrix diagrams are used to determine and represent how different variables, such as attributes, features, factors, causes, issues, or objectives, relate to one another. Knowing how things relate to each other can help in all sorts of ways, including determining quality metrics and activities needed for a project. An L-shaped matrix is a simple two-dimensional matrix that shows how two variables or groups are related to one another. In this example, it can be used to show which customers have which requirements. A T-shaped matrix relates three groups or variables. In this case, I've added location as another dimension. It relates customers to requirements and customers to locations, but not requirements to locations. It's called a T-shaped matrix because the headings or labels for the groups form a T-shape, which can be oriented vertically or horizontally. A Y-shaped matrix does a T-shaped matrix one better. It relates each of the three groups to the other two. These are a bit more difficult to read, and certainly more difficult to draw, unless you have a slick tool for doing it. So you don't see these as often. And you can represent this information using multiple L or T-shaped matrices. You can see that the Y-shaped matrix looks a bit like an upside down Y, sort of. An X-shaped matrix has labels forming a cross or X shape. It relates four different groups of variables. Each group is related to the other two out of the other three. In this case, customers are related to requirements, customers to locations, teams to locations, and teams to requirements. This could show you which requirements are required by which customers, and which teams will be working on which requirements. It also shows where each customer is located and where each team is located. It doesn't relate requirements to locations or teams to customers. The roof-shaped matrix relates a single set or group to itself. For example, this might show a list of stakeholders and what their relationships are to each other. Or it could show a list of product features and which are related to each other. Notice that you can put different symbols in the matrix to represent different types of relationships. A solid circle might indicate a strong or positive relationship, say between stakeholders. And a hollow circle could represent a weak or negative relationship. Or the solid circle could represent a strong dependency between product features, and the hollow circle could represent a weak or optional dependency. A C-shaped matrix is a three-dimensional matrix that relates three groups to each other, like the Y-shaped matrix, but drawn as a 3D image. These require some specialized software and can be rather difficult to read, so they're only used in limited circumstances. A simple but useful and commonly utilized matrix is a prioritization matrix, which is a type of L-shaped matrix, typically drawn with 4 quadrants, with each quadrant representing a different high-level conclusion or assessment or recommendation. Gartner Magic Quadrants are an excellent example of prioritization matrices. Another is Stephen Covey's Time Management Matrix from the 7 Habits of Highly Effective People, with urgency on one axis and importance on the other. We've gone through several matrix diagrams, so let's summarize the differences. We have the L-shaped, which relates 2 groups, or perhaps one group to itself. The T-shaped, which relates 3 groups, relating one to each of one of the other. The Y-shaped matrix, which relates three groups but relates them all to each other. The C-shaped matrix, which also relates all three groups to each other, but does it in a 3D perspective. The X-shaped matrix, which relates four groups, in which each group is related to two of the others. The roof matrix, that relates one group to itself. And as a reminder, the matrix diagram can be very helpful in identifying key quality metrics and activities. And that's it for part 2. PM Ready is a publication of PM Guaranteed and is based on the Project Management Institute's PMBOK guide.